there is a container which is divided into two parts with the help of semi-permeable membrane. This container is divided into two parts with the help of semi-permeable membrane. That I'm going to write it SP, semi-permeable membrane. And there is a solution. There is a solution in this container on the left hand side, that is C1, and this is C2. C1 is greater than C2, and C represents basically concentration. C represents concentration, and I just let C1, concentration of C1 is greater than C2. So see what happens, this semi-permeable membrane only allows only solvent can pass through it. Only solvent can pass through it because the size of solvent is smaller than the size of solute. And this semi-permeable membrane has basically very small pores that allows only solvent to pass through them. Solute cannot pass through them because the size of solute is greater than the pores in semi-permeable membrane. Is that clear?
Yes, sir.
So basically, from this membrane or from this boundary, only solvent can pass. So from which direction solvent can pass, like left to right or right to left? Here we will understand, like if there is two container and both container are connected with a pipe, and if you just take it, here is the water level is full and here there is no water level, or you can say the water level is very low. So can you tell me from which direction water will flow, left to right or right to left, 1 to 2 or 2 to 1? What do you think? The direction of flow of water will be 1 to 2 or 2 to 1. Rim, Samia.
Yes, sir.
So I'm asking a question. This tank is full of water. This tank is only the bottom is full with water. That means all the spaces after this bottom is empty. Will the flow of water take place or not? Yes or no?
Yes.
Yes, it will take place.
Yes, it will take place. From which direction? 1 to 2. The water will go 1 to 2 or 2 to 1?
1 to 2.
1 to 2.
1 to 2. So in the same way, for this two chamber, the chamber which has larger volume or the chamber which has greater value of solvent will go to the chamber which has a smaller value of which has lower value of solvent. Are you getting my point?
Yes, sir.
So we can define it in two terms. See, always remember that if we are talking about concentration of solution, that means we are saying that concentration of solute. It is understood. If I will say it, the acid is highly concentrated, that means the quantity of acid is more. Are you getting my point? If I'm saying concentrated acid, that means the quantity of acid is more. That means the solute is more. Okay. If solute is more, that means solvent is lesser. Okay. So I'm going to
Okay, sir.
define it. I'm going to define it. The movement of, there will be two definitions in terms of solvent or in terms of solution, solute also. The movement of solvent molecules, the movement of solvent molecules from their higher concentration, to lower concentration of solvent. So it is very simple. You know that from this semi-permeable membrane, only solvent can pass through. So the solvent will flow from higher concentration of solvent to lower concentration of solvent. See, I wrote it C1 greater than C2. That means concentration of C1 is on the left hand side is greater, and here it is lesser. But when we talk about concentration of solution, that means concentration of solute we are talking. That means solute is more. If solute is more, that means solvent on the left hand side is lesser and solvent on the right hand side is greater, because concentration of solution is lesser in on the right hand side. So the flow will take from right to left. Are you getting my point? Rim, Samia, Madiha?
Yes, sir.
Yes,
So
sir.
please write it, and then I am going to define it in terms of solute also. Hmm.
Done, sir.
Done, sir.
What about you, Madiha?
Done, sir.
Okay. So the next definition I can also write: the movement of solvent molecule, the movement of solvent molecule from lower concentration of solution, lower concentration of solution. Since we are talking about concentration of solution, that means concentration of solute. If solute is lesser, that means solvent is greater there. Lower concentration of solution to higher concentration of solution. Higher concentration of solution through semi-permeable membrane, through SPM, that is called osmosis. So please write it.
Done, sir.
Done, everyone?
Done, sir.
Yes.
Very good. Now let's discuss osmotic pressure. Osmotic pressure. For osmotic pressure, I'm going to draw a diagram. See, see what is this? Here it is P-atm. That means atmospheric pressure is applying here. P-atm. P-atm atmospheric pressure. This is basically clip piston that we can change according to our requirement. We can apply pressure according to our requirement. Here pure solution, pure solvent. Here it is pure solvent. On the right hand side, it is pure solvent. And here in this container, it's solution. That means solute plus solvent. And the most important is it is divided by semi-permeable membrane. This is SPM. SPM is the boundary from which only solvent can pass. Can you tell me whether the solvent will go from pure solvent to solution or solution to solvent side? Can anyone tell me?
Maybe from pure solvent.
Maybe from pure solvent. See, whenever we go for direction, we see where there is higher concentration of solvent, the direction will be from higher concentration of solvent to lower concentration of solvent. So since it is pure solvent on the right hand side, that means only solvent is present and on the left hand side there is solute and solvent both. So if you are going to guess where the concentration of solvent will be higher, on the right hand side or on the left hand side?
Right hand side.
Rim?
Right hand side, sir.
Right hand side. So if the concentration on the right hand side, if the concentration of solvent on the right hand side is greater, that means it will flow from right to left. Yes or no?
Yes.
Yes, sir.
So here osmosis will take place from right to left. Now, what is osmotic pressure? So see, to stop this flow from right to left or from pure solvent to solution side, we can apply pressure here. We can apply pressure here. If we are going to apply pressure, so can we stop the osmosis or not?
Yes. Okay.
Rim, Madiha,
Yes, sir.
Yes.
we can easily stop. So basically,
Yeah.
osmotic pressure is that extra pressure which stops the osmosis. The pressure applied to stop the process, this process osmosis, is called osmotic pressure. This is very easy. Just see the representation, just see the diagram. Pure solvent, it will go from right to left, and you just need to stop this process osmosis with the help of the pressure, and that pressure is called osmotic pressure. Are you getting my point?
Yes, sir.
Yes.
And now if you are going to apply more and more pressure, will the direction reverse or not? If you are going to apply more and more pressure here, the direction will be reversed. It won't see whether the concentration of solvent is more or less, higher or lower. It will reverse its direction. Yes or no? If you are going to apply with a very high pressure, it will revert back. Yes or no?
Yes.
Please
Okay.
tell me. And this is called I just told you, if you are going to apply with a high pressure, it will just reverse its direction. That is called reverse osmosis. That is called reverse osmosis. Reverse osmosis means the movement of solvent molecule from lower concentration to higher concentration with the help of pressure is called reverse osmosis. Is that clear? Reem, Samia, Madiha?
Yes.
Yes.
Sir.
Yes, sir.
So please draw this diagram and let me know. Then I will define osmotic pressure. Then we will derive a formula and do question. Then I will define reverse osmosis. Please do this.
Done, sir.
Done, everyone?
Yes.
Done, sir.
Rim, Samia,
Yes, sir.
Yes, sir. Done.
very good. Nadia, very good. Now going to define osmotic pressure. The net movement of solvent molecules from solvent to solution side, from solution solvent to solution side can be stopped, by applying an extra pressure. By applying an extra pressure can be stopped by applying an extra pressure over solution side, because they on the side of solution there is distance. Over solution side, which stops osmosis, is called osmotic pressure, and osmotic pressure is represented by, its symbol is pi. My video is hanging a lot. Let me know if you are done with this.
Done, sir.
Rim and
Yes.
Nadia. Very good, Nadia. Rim. Rim, are you done with this? Okay, see. Experimentally, we saw that this osmotic pressure is directly proportional to M, and this M is basically molarity and in some books, molarity or it is denoted by C. C also stands for molarity or concentration. Now, it also experimentally we know that pi is also directly proportional to temperature. So by combining these two, it will be directly proportional to MT. And to remove this proportionality sign, we are going to use a constant, that is gas constant. Pi is equal to RMT. And this R is basically gas constant. This R is basically gas constant that you already know from class 11. So pi will be equal to, if I'm going to write it, it will be MRT, or you can also write pi is equal to CRT. In some books, it is denoted by C. So we got a formula here. Pi is for osmotic pressure. Pi is osmotic pressure. R is for gas constant. T is for temperature. T is for temperature. And M or C for molarity. So please write it. And R has a value. Generally, we take 0.0821, 0.0821, or this liter ATM per mole per cal. Liter ATM per mole per cal.
Done, sir.
Done, everyone.
Yes.
Samia and Madiha.
Done, sir.
I'm going to give you a question. Please do this. Calculate osmotic pressure due to 5% weight by volume sugar solution at 15 degrees centigrade. Please do this question. Is my voice lagging? Madiha, Rim,
No, sir.
No, sir.
video lagging? Or what about the video?
No, sir.
No.
Please do this. It's lying for me.
Sir, can you explain this question?
Yes, why not? See, we need to, Samia, we need to calculate osmotic pressure, and only this is given. Okay. So, do you know what is the chemical formula of sugar solution? Sugar. What is the chemical formula of sugar? Anyone? What is the chemical
C12
formula?
H22O11.
O11. Very good. C12H22 O11. Very good. Now see, what is the formula for osmotic pressure? Pi is equal to M R T. Now look at the question. What is given? 15 degrees centigrade, that can be converted into Kelvin. This is given. Temperature is given. R is a constant that we can take 0.0821. What about M? So M is molarity or concentration, and you know how to calculate molarity with the help of this. In the first lecture that we started molarity, I have given some questions, or I had given some questions on this. Can you calculate molarity of 5% weight by volume sugar? Madiha, Samia, it was just a hint. Can you calculate it now? Samia, Rim, and Madiha.
I'll try, sir.
Okay. Samia, can you?
Yes, sir.
Okay, please do it.
Sir, is the answer 3.45?
8.45. No, it's incorrect answer. Wrong answer. Who said the answer is 8 point something?
Sir, I said the answer is 3.45.
Oh, that's a correct answer. 3.45. What is the unit? Kilogram, liter, meter, centimeter?
Atmosphere.
What you just said, what is the unit?
Atmosphere.
ATM. Very good. So, Samia, I'm going to explain it for you. See, pi is equal to MRT. So, we need to calculate molarity first. So, from this, we can conclude 5% weight by volume. That means 5 gram of solid solute. Solute is basically sugar here. I'm going to turn off my video because it's disturbing, lagging here. 5 gram of sugar in 100 ml of solution. So we can easily calculate molarity here. Molarity is equal to number of moles of solute upon volume of solution in liter. What will be the number of moles of solute? Given mass, that is 5 upon molar mass is 342, right? Upon volume of solution is 100 divided by 1000 because we need to convert it into liter. So molarity will be equal to approximately 5 upon 342 into if you are going to just cancel it, this 10 will be like here, it will be 50. 50 upon 342 will have the we will have molarity. 50 upon 342 molarity. So now going to put the value and you will get your answer. 50 upon 342 into what is the value of R? 0.0821 and temperature. Temperature in Kelvin is Madiha. Temperature in Kelvin is 288. We just need to add 273, and when you will calculate it, you will get approximately 3.45 or something ATM, since pi is osmotic pressure, and we took the value of R in ATM, that's why it is 3.45 ATM. So please write it. Oh, wait a minute. It was hanging a lot, that's why I just cancelled it. Please write it Madiha and Rim, and then let me know. Let me know when you are when you all are done.
Done, sir.
Very good. Samia, are you done with this?
Yes, sir.
After this, which chapter we are going to start? Okay, next question. Next question is also very easy. A 5% weight by volume sugar solution is isotonic. Do you know what does this means? Isotonic with anyone? Isotonic 0.87% weight by volume urea. Let me know if you don't know the molecular formula of urea solution. If
Sir, I don't.
okay, I'll tell you. If molar mass of sugar is 342, calculate molar mass of urea. So see, stop writing. Please concentrate here. I'm going to explain the question. A 5% of weight by volume sugar solution is isotonic with 0.87%, since sugar has a chemical formula C12H22O11. Why I asked molecular formula? Because in order to calculate molarity, you have to know the molar mass, and for molar mass you should know what is the molecular formula. And here urea has a molecular formula NH2CONH. So I'm going to explain the question first. It will be very easy for you to calculate or solve this problem. A 5% weight by volume sugar solution is isotonic with 0.87 percent weight by volume urea solution, and molar mass of sugar is given, and we need to calculate molar mass of urea. So basically this isotonic means same osmotic pressure. This means same or equal osmotic pressure. Got it, everyone? Now you can easily solve.
Yes, sir.
Please do this. Very good. Thank you. Can you solve it or should I explain it? Nadia, Rim, and Samia. Please let me know. Is there any answer? Rim?
I'm still doing, sir.
Okay. Nadia?
Sir, his answer 59.98.
Very good. Almost 60, we can call it.
Oh,
We
yes.
can say very good. Samia? Samia, your answer. No, Samia, your voice is not coming. Great. Okay, no problem. Rim, are you done with this?
Yes, sir.
Okay, you got your answer?
Yeah, I got 60.
Okay, 59.98, that means almost 60. Okay, very good. So I am going to define um, reverse osmosis. So here it is. If pressure is more than osmotic pressure, if pressure, osmotic pressure is that pressure that stops osmosis. Osmotic pressure is that pressure that stops osmosis. Now, if pressure is more than osmotic pressure, then solvent flows from solution side to pure solvent side, side, and this is known as reverse osmosis. This is known as reverse osmosis. So this is the definition for reverse osmosis. If you are going to increase the pressure more than osmotic pressure, then the flow of solvent will be from solution side to pure solvent side, and that is called reverse osmosis. Let me know if you both are done with this.
Done, sir.
Done, Madhya. So I'm going to wait a minute. This test, I'm going to take a test for half an hour, and I'm going to share the question. Before sharing the question, I would like to say, please solve it clearly in a paper and send it to coaching's contact number. And please, the answer should be clear and stepwise. So there are only 4 questions. Okay, please do.
Okay, sir.
Okay, thank you. And if you will then, yeah, if you are done with this, then let me know. Samia. Samia, am I audible to you?
Yes, sir.
Did you solve that question? Urea and all. Did you solve that question? Yes or no?
Yes, sir. I got 59 point something.
Very good, very good. So now test starts from here. There is 4 questions after 1, 2, 3, and then there will be the 4th question. You need to solve it in another paper and then send it to coaching's contact number. Okay.
So where should I send?
You have WhatsApp number of coaching.
Yes.
You just send it to that. Okay.
Okay, sir.
Thank you. Yes, sir. Let me know when you are done with the question number 1 so that I will slide it down and you will look on the question number 4.
Done, sir.
Everyone done with question number
Yeah,
first?
sir. Yeah.
Yes, sir.
So very good. Now please write question number 3. Sorry, question number 2, because question number 4 is with option multiple choice. Question number 2 done. Madiha, Rim, and Samya.
Yes, sir.
Rim,
Yes, sir.
Yes, sir.
Everyone done with question number 3?
No, sir.
Okay. Madiha,
Done, sir.
Done, sir.
Sam. Okay, very good, very good. Too fast. This will be your question number 4.
Done, sir. I sent the answer sheet.
Very good. Everyone sent it. You can send it later too. Everyone done with this? Madiha, Rim, Samia.
Yes, sir.
Okay. Can I change the screen? So you are linked to a group, right?
Yes, sir.
Yeah, everyone is linked to a group. That is, I think, name is Hassan Sir Chemistry G, right? Samia, are you in that group?
Yeah.
So
Yes, sir.
Okay, so please send it in that group. Okay. Okay, everyone. Rim, Madiha, can I change the screen?
Okay, sir.
Okay, sir. Yes, sir.
Okay. So in the next class, this chapter will be probably end, and then which chapter is going on in your school? Madiha, Rim, and Samya. Please one by one.
Sir, for me, we started chapter 4.
Chapter 4. After second solution, then 4.
No, sir. We completed the third one also.
Okay. Rim, which chapter is going on in your school?
Sir, in my school, chemical kinetics, we finished that
Okay, that
chapter.
means electrochemistry is already completed,
Yeah.
right? Okay, Madiha, what about you?
Yeah.
So, sir, for us, electrochemistry is about to get over, but now the vacation started.
So basically, after this chapter, we are going to start electrochemistry and then chemical kinetics. Okay. And if you will have any doubt, please, in any question or concept, please send message in the group. Okay. Madiha, Rim,
Okay, sir.
and okay. So thank you for today. I'll
Yes,
see you
sir.
in the next class, and probably we'll end this chapter, and then